Good afternoon, everyone. I am sharing the recorded lecture for classical mechanics. Up to now, we have seen what is the kinetic energy for the rigid body. Now, in this lecture, we are going to prove that d by dt of x, that is space set of x's, is equal to d by dt of rotational, that is body set of x's, plus omega into some quantity. This same quantity will appear here and here also. Or in another way, we have to prove that d by dt of space set of x's is equals to d by dt of some with body set of x's consideration plus w cross the same quantity. We have to take the derivative of same quantity which is appearing here. It is related to space set of x's, and here we are going to set for body set of x's. Okay, fixed set of x's means the space set of x's are nothing fixed set of x's, because this x's which are fixed in the space are called as space set of x's, and with the x's which are in the body are called a body set of x's, and which are obtained by rotating your body with some angle, just like we have seen for the last two lectures, that rotation through an angle phi, theta, and psi. With the help of that, we have found the rotation matrix, and we have found the transformation from x to x dash. In that matrix, A was obtained, which is a multiplication of B into C into D. Okay, now in this lecture, we are going to prove d by dt of, that means which is considered on a space set of x's, is equals to derivative of the same quantity on the body set of x's is equal to w cross the same quantity. What is w? Is a angular moment. Sorry, angular velocity. Okay, so here we can consider, say, a rigid body with one point fixed. As a one point is fixed means what? The there will be only rotational motion. The translation motion is absent. So this is what, say, x y z axis, and after a transformation or after rotation, it may be for, you can say it is y dash, this is z dash, and this is x dash. After rotation, it may be in the new system, that we can say the system S is related to x, y, z 3D space, and S dash is related to x dash, y dash, and z dash. Okay. Now, what is x, y, z? These are space set of x's, and x dash, y dash, z dash are the body set of x's. Okay, so here we are considering the two system S and S dash, where S dash is moving with the uniform velocity with respect to S. Okay, S dash is moving with the uniform velocity with respect to S. S dash is moving with the uniform velocity with respect to S. That means it is S dash is, we are considering this x dash, y dash, and z dash, and move with uniform velocity. We can say the omega is a velocity. Let I, j, k, and I dash, y, j dash, k dash. That means we are considering this I, j, k are the unit vectors along x, y, z, and I dash, j dash, k dash are the unit vectors along x dash, y dash, and z dash. Now we can have the position vector r can be written as. How we are going to write down the position vector? We have seen in the first lecture of our classical mechanics, which we can indicate it as xi plus yj plus zk. Say it is equation 1. Now we are writing this with respect to space set of x's or the fixed set of x's. Space set of x's, or we can say fixed set of x's. These are fixed in the space. And let me write down the r with respect to body set of x's. We can write it as x dash I dash plus y dash j dash plus z dash k dash. We can say it is equation 2. It is related to body set of x's, or we can say it is related to rotational. That is, as we are saying that it is moving with some angular velocity omega, and it is moving means what? It is rotating. Since translation motion is absent, because we are assuming that the one point of the body is fixed out. Now, whatever the equation 1 and 2 we have, now we have to differentiate these equations so that we can get whatever we want to find out. Okay, d by dt of space set of x's is equal to d by dt of fixed set of x's. Right? We have to obtain the relation between space set of x's and body set of x's. That relation we are going to find out with the help of equation 1 and 2. Okay, what we have to do for this? We have to differentiate with respect to time to our position vector. Okay. Now, what is a position vector? R in our system 1, or we can say in the space set of x's. From equation 1, we can say we have to find out derivative of r in two coordinate systems is different. Is different. Since we are going to find out the derivative of r in the two different coordinate system, that is in s and s dash, that will be different. So for that, first we are going to differentiate with respect to t the position vector r with respect to s. Okay, we write this time rate of change of r bar, time rate of change of r bar in equation 1 with respect to s is given by respect to s is given by dr by dt space set of x's is equals to dr by dt fixed set of x's is equal to, okay, we can say it is either space set of x's or fixed set of x's. Now if I'm going to differentiate our equation 1, how to differentiate our equation 1? If you want to find out the derivative of this term, it is dr by dt is equal to dx by dt, right? I declare simply unit vector, no need to differentiate them, as we are differentiating in a s only. But if you are going to differentiate in another, so you have to consider ijk also. Okay, getting me? Since here we are considering this in the space set of x's itself, because x, y, z, whatever we have written here, these are related to space set of x's only, and x dash, y dash, z dash are related to body set of x's, or we can say it is rotational, which we can write it as dx by dt I plus dy by dt j plus dz by dt k, which we can say this is our equation 3, which we can obtain by differentiating equation 1. Okay. Now let us differentiate the second one also. Time rate of change of r, which is in equation 2, with respect to s dash. That is, with respect to system s dash, we have to differentiate. We can write it as dr by dt rotational equal to dr by dt body set of x's, space set of x's, we can say. Now if we are, as we are differentiating r bar, that is related to x dash, y dash, z dash. Okay, since x dash, y dash, z dash are in body set of x's, that is in rotational set of x's. So while differentiating, I dash, j dash, k dash will be treated as a constant, because they are in the S dash itself. What is S dash? S dash is related to your X dash, Y dash, Z dash. That means S dash is a system. We can say there are two coordinate system S and S dash. S dash is nothing but the coordinate system with X dash, Y dash, and Z dash. So differentiating, we get dx dash by dt I dash plus dy dash by dt j dash plus dz dash by dt k dash. Let us say this as equation 4. What are ijk? Are the unit vector in the our S system. Ijk are the unit vector in system S. And what are I dash, j dash, and k dash? These are unit vectors in the system S dash. These are unit vectors in the system S dash, and they are constant with respect to time because these are what simply unit vector in the system and S and S dash. However, time rate of change of vector r bar given in equation 2 with respect to S is given by. That means just now I told you that if you are going to differentiate equation 1 in the space set of x's itself, it is okay. At that time, ijk are the unit vector. But if you are going to differentiate equation 1 in S dash, okay, that means you can say rate of change of rate of change of means what? Rate of change with respect to time of a vector r bar given in equation 2. Given in equation 2 means what? It is related to body set of x's if you are going to differentiate with respect to space set of x's. Okay. याला आपण आता with respect to s dash differentiate केले. That's time we are having I dash, j dash, k dash are treated as a constant. But if you are going to differentiate this with respect to space set of x's, at that time I will write down the derivative, then you can understand. So, if you are going to differentiate equation 2 in S dash, or we can equation 2 with respect to S. Okay, initially we have differentiated equation 2 in S dash, but if you are going to differentiate equation 2 in S, okay, at that time there will be a change because two systems are completely different. You can see here that figure I have drawn you x, y, z are space set of x and x dash, y dash, z dash are body set of x's. So whatever the position vector of r, say this is what r bar. So this r bar, firstly we have written with respect to x, y, z, and then we have written with respect to x dash, y dash, and z dash. Okay. Now we are going to differentiate r in the system one, that is we can say space set of x's, or then afterwards we can differentiate in body set of x's. Okay, while differentiating with respect to body set of x's, these there will be change. That means ijk and I dash, j dash, k dash will not be treated as a constant since we are in the different system. So let me write down here differentiating equation 2 with respect to t. In S, we can write it as dr by dt space set of x's. Means we are differentiating in the space set of x's. We can write it as x dash with respect to t. At that time, I dash will be as it is plus x dash as it is. Then derivative of I dash with respect to t, right? Plus next term y dash with respect to t. At that time, j dash will be as it is plus y dash as it is derivative of j dash with respect to t. Plus next we have to consider k dash dz dash by dt plus z dash dk dash by dt. Okay, this is what a derivative of our equation 2 with respect to space set of x. Now we will rearrange the term so that we can simplify this in such a way that now we will get the relation between the space set of x's and body set of x's by simplifying these equations. For that, what we will do, we will collect the terms with I dash, j dash, and k dash, that I can write it as dx dash by dt I dash plus dy dash by dt j dash plus dz dash by dt k dash plus we will write down the remaining term, that is with x dash y dash, and this is I dash with respect to t plus y dash di dash by dt plus z dash as it is, sorry, di dash by this is j, this is k, k dash with respect to t. So remaining term we have written in one bracket. Okay, now you can see what is this x dash with respect to t I dash plus this one. So you can see this from your equation number. Okay, let me show you. Where you can see from equation 4 we can say x dash with respect to t into I dash plus y dash with respect to t into j dash plus z dash with respect to t into k dash. So from equation 4 we can say it is dr by dt body set of x's. This whole term. You can write this is as this dr by dt with a space set of x's. This is here we have differentiated equation 2 in s, not in s dash. So that's why there will be a change. So we can write it as dr by dt body set of x's plus this term. This whole term you have to write here. Remaining term x dash di dash and y dash dj dash plus z dash dk dash. Now we have to simplify in such a way that we have to obtain this term as w cross something. Okay, that is angular velocity. Here you can see w cross something. So for that, let me use this. You can name it as say equation number 5. So we have to evaluate equation 5. We know the relation between angular velocity and linear velocity. What is the relation? V is equal to omega cross r. Okay. So this we can write it as dr by dt is equal to omega cross r. Right. dr by dt is nothing but your velocity. Rate of change of a position vector is a velocity. So in the very similar way, I can write what is the value of di dash by dt. Correct? Since here we have to find out those terms only, na? X dash di dash by dt plus y dash j dash by dt plus z dash dk dash by dt. To find out all these values, that means we have to first find out the value of I dash with respect to t. What is the value of I dash with respect to t? It will be equal to, just like here you can see, डेरिवेटिव r with respect to t w cross r, जो भी यहाँ पे r है यहाँ पे उसका डेरिवेटिव, right? So instead of I dash, now here we can write it as the same term for w cross I dash. Getting? So derivative of r with respect to t, here r is there, so for that I have written this very similarly. Okay, r की जगह सिर्फ I dash replace करना है. Now I hope you are knowing how to write down the cross product I dash, j dash, a dash. Many times I have told you homework to study what is a cross product, what is a dot product, what is a geometric interpretation of dot and cross product. Okay, what is I dash? I dash is a unit vector along x-axis. So that's why I have written 1, 0, 0, right? I is a I and I dash both are unit vector along x-axis. So that's why 1, 0, 0. Okay, what is W? W is with the wx, wy, wz. That is nothing but your w can be written in the component form. That is component of angular velocity along x and y and z. And first term is I dash, j dash, and k dash. Now evaluating this derivative, I hope you can evaluate. I will write directly this as w. You have to evaluate yourself while seeing this lecture. So here I get the value of I dash with respect to t as wj j dash minus k dash wy. You can in equation 5. Okay. Now what is the next term we have to evaluate? dj dash by dt, which is equal to w cross J dash. How to evaluate this W cross J dash? Just like our cross product. Again, here is I dash, J dash, and K dash. Here is a component of the vector along y-axis, so it is 0, 1, 0. I hope you can evaluate the determinant, and calculate this determinant I can write directly as minus I dash wz plus k dash wx. Let me name it as say equation 2. Since we are going to use this equation 1 to 3, that is values of I dash with respect to t, j dash with respect to t, and k dash with respect to t in our equation 5. Okay, in equation 5 we have got the relation, but simply we have to find out the last term. Let me find out the derivative of k dash with respect to t is equal to w cross k dash is equal to I dash j dash k dash, and here it is for unit vector in z axis, so it will be 0, 0, 1. Okay, so using this and solving this determinant, I will get the value of this term as I dash wy minus j dash wx. So this is what your equation number 3. Now using all these values of term, so you can say here using 1, 2, 3 in equation 5 we get. These are equation 5. First let us see, since we are solving equation 5 itself, since we are getting the relation in between space set of x's and body set of x's, this term we have to write in the form of w cross angular velocity cross some number. Okay, so using these values in equation 5 we get dr by dt space set of x's is equals to and the terms which we have obtained from equation 1, 3, 1, 2, 3, we have to write here. This is x dash, and value of I dash with respect to t is j dash wz minus k dash wy plus next term is y dash. Now we have to write down the term here. This is k dash wx minus I dash wz plus next term is the coefficient is z dash into I dash wy minus j dash wx. Okay, so these are the terms we have obtained. Now we will take the I dash, j dash, k dash common. Let me keep this as it is plus keeping I dash, j dash and k dash common. If I take I dash common, wherever you are having I dash, you have to keep it common and write the terms as this is what minus y dash wz plus z dash wy plus keeping j dash common. If I take k dash common, what I remains with this is with negative sign z dash wx minus x dash wz plus next we have to write here plus k dash. If I take k dash common, b remains within the bracket wx y dash minus x dash wy. You have to do the calculation for that. How to find out this? First make the terms. Collect the terms with I dash, collect the terms with j dash, collect the terms with k dash, and write it. Okay, writing this, we get this in the form of I dash and one bracket j dash k dash. Okay, now whatever the terms we are getting here, let me keep this as it is. We are not having any objection related to this since we are getting it as space set of x's is equals to dr by dt body set of x's plus whatever the terms we are getting here, You can see this. This is just like our uh, determinant. What is there in this determinant? You can say this is with I dash, j dash, k dash. That's why I've written j dash with a negative sign. So that after evaluating, you have to go in the reverse way now. Okay, solving this determinant, you will get the previous step. Okay, ये determinant जब आप solve करोगे तो आपको previous step मिलेगा. That's why I've written j dash with the negative sign. And you can see here, this is what wx, wy, and wz. And the last one is x dash, y dash, and z dash. If you want to verify, you can solve this determinant. No doubt, definitely you are going to get the previous step. If you're not having a faith on me, you can solve it. Or those, no doubt, you should not have a faith on anyone. That means rather you were, it may be teacher. So this term I can write it as W, that is component of W in the x, y, z direction. Cross product with R bar, that is with x dash, y dash, z dash. These are nothing but I am writing as a position vector with respect to S dash system. R bar is x dash, I dash, y dash, j dash, z dash, and k dash. Okay, x dash, I dash plus y dash, j dash plus z dash, k dash. So here we got this in the form of this term. So hence, now R is arbitrary. That is, R is any position vector. So you can eliminate this. Let me write down once again so that you can understand it. dr by dt space set of x's is equal to dr by dt body set of x's equal to, now this r is any position vector, so we can eliminate this r and hence we can write it as d by dt of space set of x's is equals to d by dt in the body set of x's plus w cross that. See, we have followed here in this lecture, we have seen we have to find out the relation between fixed set of x's and rotational, and or rather we can say it is space set of x's and body set of x's. To obtain this relation, what we have done, we have considered the two systems S and S dash. S is related to x, y, z, and S dash is a system related to x dash, y dash, and z dash. So S dash is what? It is moving with some uniform velocity omega with respect to x. That is, it is with some rotation. Because since if you are going to fix out to one point of the body, translation motion is absent, so it is simply rotating. What are unit vector now? X dash, y dash, and z dash. So now firstly we have written the position vector with respect to space set of x's, then we have written the position vector with respect to body set of x's. Okay, then afterwards we have differentiated equation 1 and 2 in their own space set of x's. First one is in the space set of x's, secondly we have differentiated in body set of x's. So we have obtained equation 3 and 4, and after that we have to now find out the relation. So for that we have to differentiate 2 with respect to space set of x's. Equation 2 है body set of x's मत लिखिए, I dash, j dash, k dash will not be treated as a constant. So we have to differentiate them. After differentiating, keep terms in one bracket and you will get the value of first bracket as a from equation 4. What is the value of first bracket from equation 4 is dr by dt body set of x's. Now to solve the equation 5, we have to just find out the value of a last bracket, that is x dash y dash with respect to t plus y dash j dash with respect to t plus z dash derivative k dash with respect to t. Finding their derivative with the help of relation between angular velocity and linear velocity, we get the relation equation 1, 2, and 3. And then by using the value of property of a determinant, we get the result. Since r is any position vector, we can write this equation. Okay, thank you for watching the lecture.